Hello, this is a small introduction to computer number control. Although it's a simplified version of computer number control, CNC, it is still what the industry uses today to do manufacturing. We manufacture a lot of parts in this method because it enables us to make multiple parts very accurately and quite fast. It's much easier than having somebody sit on an assembly line and make a part by hand. It's used all over the world today, and very likely many things that you own in your home are done by this process. And what I'm going to do to demonstrate that process is I'm going to put a piece of engraving stock, and this is engraving stock. I'm going to put a piece of engraving stock on a table on a milling machine. This is a milling machine, and we're holding this engraving stock with this plate. This plate holds the engraving stock down and also allows it to be oriented very carefully, because we need absolute orientation. We have to know exactly where we are in order for the computer to know what to cut and when to cut it. So what we're going to do here is I have put something in, and you notice I already started cutting it. I have stopped the program partially. Now what we have here is a high-speed motor, and the high-speed motor has a cutter on it, and the cutter will cut through this engraving stock, which is a two-layer stock. The top is blue and underneath it is white, which is much thicker. When we cut through the top stock, it cuts into the white so that we have an image that comes out as we cut through it. Now what I'm going to do is start running the lathe, and then I will show you the process as it moves along and how it's done. Let me start the lathe. Okay. See if I can pan in a little bit. I'm limited a little bit here because I have a flip camera, and it unfortunately only has so much magnification and so much zoom. But you can see that it's cutting into the engraving stock. It's cutting quite accurately, but you can't see that from here, unfortunately, because of the fact that this camera doesn't have the resolution. Now what's happening is this axis here is moving up and down. Right here with the bit on it is moving up and down. As that's moving up and down, the front stepper motor is also moving. You'll see that moving. That's an orientation for the table. There's a table with an X and Y axis also. So we have three axes here, an X axis, a Y axis, and a Z axis. And you don't have to know that. What that means is that it allows us to constantly move this product around in a very, very exact way so that we can establish exactly what to cut, how deep to cut it, and what the dimensions of that cut are. Now you'll see that this is cutting into this stock completely through these motors again. Now there's another motor I'm not showing you here, but there is one on the other end. Now the process, the whole process starts with something called CAD. Just let me stop this for a minute so that you can hear me speak. The whole process starts with something called CAD, computer-aided design, and a computer-aided design is merely a drafting program, basically. It's a refined drafting program, what drafting used to do on a table, but it's a drafting program that we do on computers. Now we draft the part that we want to make. Let's say it's a simple flange. We draw that on our computer in the CAD program, the computer-aided design program, and then that file, usually a DXS file or DXF file, or some other similar file, is sent to a CAM program, a computer-aided machining program. The computer-aided machining program gives us an interpretation that we can use in our final program that allows us to send that information to the machine itself from the computer. And that final program converts the G code, which is the output of the CAM program, into a program, into an interpretation that allows us to run each motor. And these motors are special motors, and what they do is they step a certain amount for every bit in our computer. So if we want to step 5/1000ths of an inch, then this motor can take so many steps to enable us to have that 5/1000ths of an inch. And that's what you see when you see that motor going back and forth. That's an interpretation from the final program, in this case Mach 3, that allows it to move our table back and forth. Hold on now, and what I'm going to do is show you a final. I'll just let you see this one more time here, and then I will I just want you to see this one more time as we move along. I don't know if I can get it any closer. I can try. As you can see it cutting, and now it'll start cutting the next word on our sign. Okay. There you go. Now you see cutting the next word. Okay, now I'm going to stop this program, and I'm going to show you the final thing, and I will give you a little outline of what we have done so you get a pretty good idea of how this CNC works. Okay, before I go and show you the final part, what I want to show you is the computer screen of the program that we use. Sorry, McAfee shouldn't be in here. This is the final computer screen, and this is what the screen looks like for the program that interprets the G code that drives the stepper motors. And this program again is called Mach 3, and it works very well. Up in the right hand corner you can see it's a little tough to see, but that's the sign that we're making. That's the engraving that we're making in the etching stock. And on the left is all of the numbers for the G code. And what happens is, as the program finishes one step, it steps down to the next step, and you can watch the progression on the right as it moves from one point to the next point in the machining process. And underneath this, down in here, are all of the levels of different interpretations that we can make, and how fast we can make our motors run, and so forth and so on. And there are other sections here that we can do different things with our program. We can write our own G code, and it gives us all of the different G code or M codes. We can do M codes here too. This is all part of this machining process, and people write these codes down by hand. Okay, now I'm going to go along and I'm going to show you the final sign, and I'll give you just a wrap-up. Okay, here's our final little plaque, and this is all has been done on the CNC machine. Again, I'll give you a little rundown. First, we have a CAD program, which is a drafting program. We draw our design in the drafting program, whatever that part might be, and we send that file to a CAM program, computer-aided machining program. That computer-aided machining program interprets that drawing into and converts it into a G code. The G code then goes to a final program, in this case Mach 3, and Mach 3 interprets that G code into a mechanical movement for each one of these motors, these special stepper motors that make our machine go back and forth. You can do it with stepper motors. A little faster is servo motors, but they all do basically the same thing. If you see a big welding, when you watch a car on an assembly line and you see all the big welding machines as the car moves down the assembly line, that's computer-aided welding, and it's basically the same process. It's a computer number control process with a different machinery, but it's all basically run the same process. I hope that you've enjoyed this little video and this introduction into how we manufacture and make things, and I've enjoyed getting it to you. Thank you.